Hi, I'm Murdick, and today we're going to talk about union and intersections of sets. Okay? And this is page 8 in your textbook. And given this set A, notice I've got a set of integers here, but they really could be anything. We can call them elements, but in this case they are integers. And another set B, we call B of more integers here. And I want to know what the union of these two sets are. That's kind of what the question I'm going to ask here. The union of two sets, dash, A or B, and we refer to it as A or B, or we use this symbol for A union B, which means A or B, consists of all the elements in both sets without repeats. Okay, all the elements. So I go over here, and we're going to move over to this board, and we're going to make this set A union B, okay? The union of these two sets. And so I have to include what? If I go back here and I look at that other set, if you've stopped the video and copied down the sets, which you should, I've got -3 in that first set, 5, 7. If you want to flash over there a little bit to show where I'm getting these numbers, 11, 0. That's all the integers in the first set. I have to include the integers in the next set. -10, I have to include that. 5, we don't need to include that. That will be a repeat. And it's 4. 4 is not a repeat, but 0 is a repeat. And so here we have the union of the two sets, don't we? A or B. In other words, if an element is in A, then it's in here. If an element is in B, it's in here. A union B, and that's the union of A and B. Now coming over here to this board here, the intersection of two sets, dash, which we refer to as A and B, or we refer to as A upside down U here and B. One way to remember this means and is you draw a line that makes an A, right? And so that's just a little trick, but it is an upside down U. This consists of all the elements really common to both sets. All the elements they have in common. So I look over here at the two sets, if you can move the video over, and I see, well, -3 is not common. Well, 5's in both sets, right? 7 is not, 11 is not, 0. Only 5 and 0 are common to both sets. So I put a 5 here and a 0 here. And I make my little squiggly bracket there. And that is A intersection B, or A and B. Each element is both in A and B. Okay, let's go swing over to this board over here, and we're going to talk about, really, what it concerns us in the textbook, which is the union and intersection of intervals, okay? And here I've drawn an interval. I'll call this set A, and you notice here that this interval consists of all real numbers. This is a real number line here, of all real numbers from -2 to 5, but not including -2. And when we write it in inequality notation, I write -2 less than x, less than or equal to 5. And this is called interval notation here. Notice I have -2, 5, all the numbers between -2 and 5. The round bracket indicates that we don't include -2, but the square bracket means we include 5. By the way, if you write x is greater than, or say less than -3, and you want to write that in interval notation, you would write -∞, -3, and you put a round bracket there and a round bracket here. You have to put a round bracket on -∞ because it's not a real number, and you put the round bracket on -3 because you're not including a -3. That's just a little aside. I'd like to mention that about infinity. You never put a square bracket on infinity. But let's get back to where we were. Here I have set A that goes from -2 to 5, includes 5, doesn't include -2. And here I have set B, which is all the real numbers from -4 to 1, but we're not going to include 1, but we include -4. And what I want to know is, what is A union B? In other words, if a point or a real number is in this set, then I have to include it in A union B. Or if it's in this set, I have to include it, okay? That's where the or comes from. I have to include it if it's in either set. And you can see that I have to include -4 plus all the numbers right through 2 all the way up to 0, 1 here. And then I have to include 1 because it's in this set all the way to 5. So really I'm going to include all the numbers from -4 all the way to 5. Okay, and I have to put a solid bracket there and complete it like that. And if I were writing in an interval notation, I would write x greater than or equal to -4, less than or equal to 5. This is a little small, maybe you can read this. This is x greater than or equal to -4, less than or equal to 5. And in interval notation, I'd have to use the square brackets. I don't know if you can see this. I'm going over here, -4, comma, 5, end of square bracket. So the 3 ways of notating A union B. Here's a graph, here's an inequality, and here it is in interval notation. And all the x's between, all the real numbers between -4 and 5, including -4 and 5, are in the union of these two sets. Now the intersection, remember I'm going back to these two here. The intersection is only the points they have in common. I look at this thing, I kind of draw a little dotted line here, and I can see that all the points they have in common are going to be between here, and you can't include -2 because it doesn't have -2 in common, and you can't include 1, which this is 0 here, and this is actually 1 here. So it's going to be just this, just between -2 and 1 are the points they have in common, and so, and they don't include -2, and they don't include 1. So here they are. So when I go ahead and write an interval notation, it's going to be x greater than -2. Make sure I got this right here. 2. And then less than 1. I think that's correct, like that. And then if I go over here, it's going to be a little bit small. -2, comma, 1 with round brackets on both. Okay? So here we have A and B, and here we have A union B, the set of all the points they have in common. A intersection, I'm sorry, let me say it again. A union B, all the points in either set are in there. If they're in one set, they have to be in here. If they're in the other set, they have to be here. But A intersection B, only the points they have in common. Good.